We've talked about completing the square in the simplest form when the first coefficient a is equal to 1. Now we have a circumstance here where we can use completing the square to take a quadratic expression in a function and turn it into graphing form or vertex form. The way that we do that is using completing the square in a more complex situation where a is not equal to 1. In this case right here, a is equal to 2. Here's how it goes. The first thing that we're going to do is actually take a as a factor out from the first two terms of the function that is given to us. And so now we're going to write g of x is equal to 2 in parentheses x squared minus 4x. And we're going to finish our parentheses off wide, and there's a reason for doing that. And then we're going to put that third term plus 1 out beyond the parentheses. So now we can complete the square because there's a rule that you may not complete the square if a is not equal to 1. Well, a is equal to 1 now inside the parentheses. Now we can actually do it this way. Take that negative 4 that you see inside, divide it by 2 and get negative 2. Then take negative 2 and square that and get 4. Now I'm going to change the color of my pen here to show you that now when I'm adding 4 here, but I'm subtracting 4. So really what I'm doing is I'm adding 0 because 4 minus 4 is 0. But what we're going to do, and I'm going to put a set of purple parentheses in here and show you that that trinomial now is a completed square. So if we treat it that way, that completed square is x minus 2 squared. And I'm going to draw the rest of what we have in there, 2, and I'm even going to put in green the minus 4. So you're seeing clearly where that's coming from and call that plus 1. The next step is to multiply using the distributive property that 2. So when we do that, we get 2, and we can't multiply that into the squared expression, so we just write the squared expression. And then minus 8, because negative 4 times 2 is 8, plus 1, it comes from the outside. And now we can combine the minus 8 plus 1 and call that minus 7. And this is 2 then times x minus 2 squared, and that's my g of x. In total, it's g of x is equal to 2 times x minus 2 squared minus 7. And I want you to recognize this is now in vertex form, where h is equal to 2 and k is equal to negative 7. So we have a vertex of 2, negative 7, and we have a stretch vertically of 2 from this guy right here. We're going to take that now and show you that we can type g of x equals 2x squared minus 8x plus 1. And what I'm wanting to show you here is that in doing that, we have a vertex of 2, negative 7, which is the vertex that you see here. You'll also notice that if we go 1 to the left, that we actually have to go 2 up in the scale that you see here to show that a is equal to 2, because normally 1 to the left means I'm only going 1 up. If we go 2 to the left, 1, 2, then I should be going 4 up now, but now instead I'm going 8 up. So here is 1, 2, 3, 4, 5, 6, 7, and 8. And that's 2 times what is usually 4 when I get 2 points away. So I'm wanting to show you that this parabola that is shown on Desmos is indeed what we started with, and that if we type it the way that we found it when we completed the square, we can say g of x is equal to 2 times, in vertex form, x minus 2, and that squared minus 7. And you'll see that if I just plot the blue, it's right there, but if I plot the red, it's the same parabola. And so those are the two different forms that we got because of completing the square. Here's another situation where a is not equal to 1, and we want to use completing the square in order to find the vertex form of f of x. Note that a is equal to negative 3, and so I'm going to start things off by factoring out negative 3. So the first term is negative 3, and I'm going to put some parentheses in and say x squared plus, and negative times negative gives me positive, so I'm going to say negative 4x, and close that off wide, and put the negative 7 outside because I didn't factor anything out of negative 7, so just negative 7 stays on the right. Now I'm going to clean this up a little bit before I actually do some action. I'll rewrite this way. Negative 3, x squared minus 4x, close it wide, and then minus 7. I'm going to take what's inside the parentheses, and I'm going to take the second term, negative 4, and I'm going to divide by 2, and I get negative 2. And I take negative 2, and I square that, and I get 4. So I'm going to say plus 4 and minus 4. And then I'm going to put a set of purple parentheses inside and show you that that now is a completed square. And the reason why it's a completed square is because it's really another way of writing x minus 2 squared. And then I need to put that minus 4 and put that outer set of parentheses and the negative 3 in front. The next thing to do is to distribute the negative 3 into the outer set of parentheses to remove that outer set of parentheses, and we get negative 3x minus 2 squared. Negative negative is positive, plus 12 minus 7. And you'll see then that this is our new f of x written in vertex form. Negative 3x minus 2 squared, and 12 minus 7 is 5. This is in vertex form, so vertex is h is 2 and k is 5. So the vertex is located at 2, 5, and we have a vertical stretch of negative 3. So it's going to flip it upside down and make it negative 3. We're graphing this. That means that we're going to be to the right 2 and up 5. Now if we do Desmos again, only using the f of x that we started with, f of x is equal to negative 3x squared plus 12x minus 7. If we look at that, we're looking at a parabola that has been turned upside down, and note where the vertex is. The vertex is located at 2, 5. So h is 2, k is 5, just like we wrote it when we wrote it in vertex form. But it's upside down, that's the negative part, and everything should be 3 apart from how things go. So these boxes are separated by distances of 2, and so if I go 1 to the right, that means I would go 1 down if it was not a multiplier of 3, but it's a multiplier of 3, so we're not going to go just 1 down. We're going to go 1, 2, 3, and there we are on the parabola. That means we go down 3 times 4, which is 12. So if I start here at the vertex and I go 2 to the right, 1, 2, then that means I'm going to go 4 times 3, which is 12, down. So let's see if we got that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're all the way down to where we need to be to show that this is a parabola with a is equal to negative 3. Here's one I want you to try. Let's complete the square where a is not equal to 1. Okay, I'm going to do my answer now in 3, 2, 1. So the first step is going to be to take that 2, which is a, because a is equal to 2. And so we're going to take that 2 and we're going to factor it out of the first 2 terms. And we're going to leave space inside our parentheses when we do that. So I get 14x, nice big space, plus 88. All right, we're going to take that 14 and divide it by 2, and we get 7. And we're going to take 7 and we're going to square it, and we get 49. And we're going to add 49, and we're going to subtract 49. And we're going to put parentheses on the inside around the trinomial that is now a perfect square trinomial, or a completed square. And we can write it then as x plus 7 squared. We're going to write the minus 49. We're going to write the 49 and still have the parentheses on the outside of that with the 2 plus 88. The next step is to distribute the 2 back into the parentheses so that we're removing the outer set of parentheses. And so that becomes 2 times x plus 7 squared minus 98, which is 2 times 49 plus 88. And now we just combine negative 98 to positive 88, which is just negative 10. And we've got the 2 times x plus 7 squared. And that's my new form of g of x. And you'll see that that's exactly the same. If you graph this on Desmos and graph this on Desmos, we end up with h is equal to negative 7. We're going to go to the left 7, and we're going to go down 10 because k is equal to negative 10. And there's going to be a stretch of 2. And so it's going to be a parabola that's twice as tall as it normally is, but its vertex is located at negative 7, negative 10. Here now is another application of completing the square that's a little bit more complex than the original way that we taught it to you. So here, what I'm wanting you to see is that I have x squared and y squared. And let's see what we get when we do this. Now the first thing I'm going to do is I'm going to group together my x squared term and my single x term. So it's x squared minus 8x. I'm going to leave a space, and I'm also going to put y squared plus 6y. And I'm going to say equals negative 9 right here. And so watch how this goes. We're going to actually complete the square twice in this equation. The first one, for the x's, I'm going to take the negative 8, and I'm going to divide it by 2 and get negative 4. And I'm going to take negative 4 and square that and get 16. Now I'm going to add 16, and I'm going to subtract 16. Now we're going to do the y's. So the y's, we're going to take 6, and we're going to divide that by 2, and we get 3. And we're going to take 3, and we're going to square it and get 9. And so I'm going to add 9, and I'm going to subtract 9. Now, I want you to see that I've created two quadratic trinomials that are completed squares. So this can be rewritten as x minus 4 squared minus 16, because I still have that makeup piece, plus y plus 3 squared minus 9, and that equals negative 9. Now I'm going to add the 9 over, and I'm going to add the 16 over, and let's see what we get. This goes away, negative 9 plus 9 go away, and I'm left with 16. And I have x minus 4 squared plus y plus 3 squared. Do you recognize it? H is equal to 4, k is equal to negative 3. This is the equation of a circle with a center at 4, negative 3. And the radius is square root of 16, that's 4. This is the equation of a circle. And we'll be talking about that as we get further into talking about the quadratic equation in two variables. Here's another one I'd like you to try. Notice we've got an x squared and an y squared in there, so you know what you need to do. So give it a go. All right, here's my answer in 3, 2, 1. I'm going to rearrange my x's and y's so that they're all together and I can work with them. So I'm going to take x squared and I'm going to combine it with the minus 10x. And I'm going to leave some space so I can work, and I'm going to say y squared, and I'll put a plus sign in front of that, and put minus 12y. And leave some more space and put my negative 36 at the edge there. We're going to take the negative 10 because that's the second coefficient for the x's. We're going to take that, divide it by 2, and get negative 5, and take negative 5, and we're going to square that, and we get 25. That's what we're going to add, and that's what we're going to subtract. And we're going to do it again, only with the y's. So the second coefficient has negative 12. We're going to divide that by 2. We get negative 6, and negative 6 squared is equal to 36. I'm going to add that 36, and I'm going to subtract it. And that turns this trinomial and this trinomial into completed squares. So we can write them as the completed squares that they are. This is x minus 5 squared minus 25 plus y minus 6 squared minus 36. And that's all equal to negative 36. If I add 36, that goes to 0 over here and goes away over here, and add 25. Now I have 25 is equal to x minus 5 squared plus y minus 6 squared. So we have a circle. It's located where h is equal to 5 and k is equal to 6, and the radius is equal to 5 because the square root of 25 is 5. Our center is located at 5, 6, and our radius is 5.